Hi students, I hope you are doing good. So in this part, I will be discussing about some of the previous IIT-JEE questions and IIEEE questions. So let's not waste our time. I know you are very much excited for this part, so we'll start it. Previous year JEE, IIEEE and BITSAT questions. So previous year questions. The first question, in context with the transition elements, which of the following statements is incorrect? First, in the highest oxidation states, the transition metal shows basic character and form cationic complexes. Yes, we have seen that as the oxidation state increases, what happens is that the given metal forms complexes, right? And also when the oxidation state increases, their basic character also comes into the picture. So this is correct. In the highest oxidation state of the first 5 transition elements, all the 4s and 3d electrons are used for bonding. No, right? So in the higher oxidation state, obviously the 4s electrons won't be used for bonding. Only 3d electrons are used for bonding, right? Because first the electrons are removed from 4s itself. Once 4s electrons are removed in a given oxidation state, obviously only 3d electrons are left and they are used for bonding. So this is wrong answer. Once the d5 configuration is exceeded, the tendency to involve all the 3d electrons is bonding decreases. So once you achieve d5 configuration, what happens? It becomes half stable configuration. So once d5 is exceeded, for example, you are getting d6. What happens to tendency to involve all the 3d electrons? The tendency actually increases, right? Because now the leftover 3d electrons are used for bonding. So this is increases. So this is also wrong answer. In addition to the normal oxidation state, the zero oxidation state is shown by these elements in complexes. So yes, in addition to the normal oxidation state, the zero oxidation state is not shown, right? It should not be not shown. So this is also wrong answer. So the answer is 1A. Next one. In context of lanthanides, which of the following statements is not correct? So let's recall the concepts of lanthanides. So the first is there is a gradual decrease in the radii of the members with increase in the atomic number of this series. So this is correct, right? This is happening because of lanthanide contraction. This is happening because of lanthanide contraction. So obviously there is a gradual decrease in the radii of the members. Second, all the members exhibit +3 oxidation state. Yes, right. We have also discussed for lanthanides, +3 oxidation state is the most stable. So because of the similar properties, the separation of lanthanides is not easy. This is also a point which we have concluded, right? Because again, if they have same atomic radii, obviously it will be difficult to separate. Availability of 4f electrons result in the formation of compounds in +4 state for all the members of series. Remember, we have also discussed that the +4 oxidation state is not possible for all the members of the series. It is only for certain members of the series. So this is a wrong answer. So in the question it is asked, in context of lanthanide, which of the following is not correct? So D is the option. Next question. Iron exhibits +2 and +3 oxidation state. Which of the following about iron is incorrect? So ferrous components are less volatile than corresponding ferric compounds. Absolutely correct. Ferrous components are more easily hydrolyzed than corresponding ferric components. So if we have ferrous and ferric, so +2 oxidation state and +3 oxidation state actually refers that which is ferrous and which is ferric, right? But very important thing which you have to understand is that when you have ferric compounds are more easily hydrolyzed than corresponding ferrous compounds. So obviously 2 will be the wrong answer. Next, ferrous oxide is more basic in nature. Absolutely correct, right? Since you know that higher is the oxidation state. Remember, +3 ferrous, +2 ferric. So you know already that higher is the oxidation state, more is the basic nature. This is also correct. Next, ferrous compounds are relatively more ionic than the corresponding ferric compounds. No, I mean when compared to the ferrous compounds, obviously ferric compounds are less relatively ionic. So this is also correct answer. So ferrous compounds are relatively more ionic than the corresponding ferric compounds. So the answer is B, because ferric compounds are more easily hydrolyzed than the corresponding ferrous compounds. So it should be the vice versa. For successive members of the first row of transition elements are listed below with atomic numbers. Which of them is expected to have higher EM3 to EM2 plus value? So this is again interesting. So you have to actually see Mn3 plus to Mn2 plus, Fe3 plus to Fe2 plus, CO3 plus to CO2 plus. So you are talking about the reduction here, Cr3 plus to Cr2 plus. So what is the configuration of manganese? Manganese is 4s2 3d5, iron 4s2 3d6, cobalt 4s2 3d7, and chromium 4s1 3d5. So here you can see here that let's consider cobalt. So cobalt 3 plus is nothing but 4s0 3d 4s0 and 3d6 configuration, because you are removing an electron, right? So what you are expected to have is that you have to have the highest reduction value. So here the interesting thing to know is that since you are actually adding an electron, since reduction is taking place, so what is happening here is that, so you are getting 4s0 3d6 configuration, and for cobalt it will be cobalt 2 plus. So it will be 4s0 3d7 configuration, right? But what is happening here is that since you are adding electron to this 3d, and what is happening is that when we are talking about the reduction values actually are increasing along the period for the same type, right? So you can see that you have manganese, iron, so manganese atomic number 25, iron 26, cobalt 27 and chromium 24. So cobalt has the higher atomic number. So obviously if your atomic number increases, and the same phenomenon is happening here, you can see that you need more energy along the period. So obviously cobalt with higher atomic number in the same period needs more reduction potential value. So obviously cobalt needs more reduction potential value since it has atomic number of 27, which is the highest in the given options. So next, which of the following arrangement does not represent the correct order of the property stated against it? So ionic size, you know that ionic size of Mn2 plus is not greater than Fe2 plus. So Mn2 plus is greater than Fe2 plus, and which is greater than CO2 plus and Na2 plus, right? So obviously now we have to consider the effective nuclear charge. So you can see here the effective nuclear charge is higher for Mn2 plus. This is the correct one. Next one, stability in aqueous solution. So we know that stability in aqueous solution depends on their ability to bond with your hydrogen molecules of water. So you can see here that, and also along a given period that stability increases, but this is the reverse order, right? It should be like this. So this is a wrong one. So next, number of oxidations, obviously manganese is greater than chromium. So because of presence of more number of unpaired electrons in the d orbital. So this is also correct one. Next, paramagnetic behavior. So paramagnetic nature depends on the number of unpaired electrons, but Fe2 plus has less paramagnetic behavior than Mn2 plus. It should be the reverse order. So this is also wrong one. So the answer, so the incorrect is B and D. Right, so this is a multiple answer type. So students, so this is all about the previous JEE questions. So we have finished this topic of D or F block elements or inner transition elements. So let me give a glance what we have discussed till now. We have basically started with the transition elements. We have studied what are the transition elements and what is the difference between transition and D block element. Later on we have discussed about the properties like magnetic properties, the properties of oxidation state. We have discussed about the catalytic properties, the properties of complex compounds, interstitial compounds. We have discussed about their ionization enthalpies. Right. Later on we have discussed about the inner transition elements, the series present in inner transition elements, the difference between F block element and inner transition element, and we have discussed the properties of lanthanides and actinides. In the last we have discussed about some previous JEE questions and other competitive examination questions. So this is the end to this chapter of transition on inner transition elements or D or F block elements. So I hope you enjoyed this part, and for any other videos in maths, physics or chemistry, just go to our website www.askIITians.com and you can find very interesting topics related to these subjects. So take care of yourself guys. I hope you enjoyed this part. Goodbye.